Right from your pre-C, you have been calculating the kg of the vessel. By how? By principle of moments. Okay, about keel. Right now, in all those questions, the starting kg of the vessel is given to you in the question itself. What are you actually doing? You are actually allowing for the changes that have been made by way of loading, discharging, or shifting. So you make those changes in the given kg and you come out with the kg of the vessel in the final condition, which you have been calling as kg final. Correct, guys? You have been doing this, right? Okay. Now the thing is, you are given a condition, it's fine, but somewhere but you can basically, what I said was, yes, if given the initial condition, you can account for the changes and get the final condition perfect. But where does the initial condition come from? It will come from an earlier initial. That will come from something preceding it. That will come preceding it. That means where is it taking us to? Basically, it is taking us to how do we get the light ship. Okay. Now that is the actual objective. You can use your knowledge of moments and keep allowing for the changes that have been made to the light ship, and you can always get the kg of the ship. Yes or no, guys? What is the principle involved in the experiment? Okay. Now, what is the principle involved in the experiment is that when you want to get the kg of the ship in a given condition, whatever it is, and you do not know anything about earlier kg and things, then what can you do? You have a ship, okay? Now, on that ship, you have the ship in the upright condition with some known weight here. This weight is known, and the ship is in the upright condition. Okay. Now, if I shift, since this weight is known to me, and I shift this weight transversely through a certain distance d, then we all know it will cause the vessel to list. Yes or no, guys? What is the formula for the list?
Tan theta is equal to W into W upon W into
G1 transverse
G1 upon G.
GM, which
GM.
translates into W into D upon capital W into GM. Correct, Bete?
Yes, sir.
Which I know, then I know the W that I'm shifting. I know the distance through which it has been shifted. We will, by taking the drafts of the ship, I can get the displacement of the vessel. And if I can measure exactly the list caused, so that means by shifting of this W weight, if I can measure the theta, the list caused, then what do I know in this expression? I would have theta, I have W, small w, I have D, I have capital W. What is missing is GM. So this experiment, by measuring the list caused, I can obtain the GM. Yes or no, beta? The GM of the ship in whatever condition the experiment was performed. Now, if the ship was theoretically light, then it will be light ship GM. If the ship was not in light condition, because ship cannot be practically absolutely in light condition when you perform the experiment. So in whatever condition you perform the experiment, this will give you the GM of the vessel in the condition in which experiment was performed. Okay. Since you already know the displacement of the vessel, you can go to the hydrostatic particulars of that ship, and from the hydrostatic particulars, you can find out the Km in the experiment condition. So now you have obtained the GM in the experiment condition. You have got the Km in the experiment condition. I am sure all of you know that this GM that you'll obtain will be GM fluid, because when the list is caused, if there are any slack tanks, the liquid will also flow. So we will we'll evaluate the tank conditions of our ship when the experiment is performed, and we'll find out which all tanks were slack, and we can find out the FSM of those tanks, and that can give us the FSC in the experiment condition. Now, when I add this FSC to the GM obtained through experiment, which will be GM fluid, this will give us GM in the experiment condition, but this will be GM solid. And this GM solid, if I subtract from AM experiment condition, this will give me the kg of the vessel. In which condition? In the condition in which the experiment was performed. So I can get the kg of the ship in the experiment condition. Guys, any questions up to this experiment? We measure the list. On the ships, you read it through the inclinometer. But obviously, inclinometer cannot give you very accurate list. You can say 1 degree, 1.5 degree, 1.25 degree. You can't say 1.1 degree because the scale is so small. And the accuracy of the experiment will depend on measurement of theta. If you make a mistake in measuring theta, naturally all your results will be haywire. So how is the theta measured, or how is the list measured? Now, to measure the list more accurately, what is done is we make use of pendulum. A pendulum is suspended on the bulkhead on the center line. Okay, here it is suspended. And we also take a graduated scale which is fitted to the bulkhead. So this is graduated scale which is fitted to the bulkhead, and pendulum is suspended here. This is the upright condition with the weight being here. Correct, guys? Is that clear? This time the list is 0. And this distance from here to the graduation, this is called as the length of the pendulum. This is called the length of the pendulum. We are not going up to the tip of the bobber, right? We are only going up to here, where the graduations are on the upper part of the scale, and the length is only up to this place. And why we have taken more, you'll see when I make the next diagram. Now this angle is 90, obviously. Any questions in the upright condition? This is the pendulum we have suspended. We have a graduated batten. Vessel is upright with the weight in the blue position, right? The vessel develops a list. I'm exaggerating the list. That will depend on how much weight is shifted and what is the displacement and all those things. I'm just exaggerating the inclination. So now the weight is no more here. The weight is no more here. The weight is here. It has been shifted through a distance d. Now what happens? This scale, which is fixed to the bulkhead, as the ship inclines, the scale will also incline with the bulkhead. Yes or no, guys? The scale will incline with the bulkhead because the scale is fitted to the bulkhead. Yes, but the pendulum, because of gravity, will remain vertical. So the pendulum will remain vertical. Scale has tilted with the bulkhead. The pendulum remains vertical because of the gravity. Okay. This angle we have already said is 90, and this length we have said is the length of the pendulum from here to here, guys. Now you see why the length of the pendulum was taken more than what we are calling is length, so that it is always on the graduation. We can precisely read from the thread where it is touching the graduation, right? That's why it was taken a little longer. So we don't take the length up to the tip of the bob. We take it up to the graduation scale. Okay. Obviously, guys, this angle will be theta. Okay. And this much of thing on the scale, you can read from the scale, and this is called deflection. So what you can read from the scale is, graduated scale is, this part can be read on the scale, and this is called as deflection. This is what is called as the length of the pendulum. Am I clear, guys? This angle is 90. Yes or no? What do we get? Tan theta is equal to deflection upon length, perpendicular upon base, right? And in the first, and by the list formula, we also have this tan theta is equal to W into D upon W into GM. This also we know. Now in equation 1 and equation 2, left hand sides are same. So the right hand sides can be equated. And when you equate the right hand side, it becomes the deflection upon length is equal to W into D upon capital W into GM. You bring GM on one side and take everything else on the other side. So GM is equal to small w into D transverse through which it was shifted, multiplied by the length of the ship, divided by the displacement of the ship, and also the deflection. This becomes the formula for the GM by after you read the deflection from the scale. Correct, guys? If you comes in theory, whatever I've explained, it can become part of your theory answer if principle has to be explained. Otherwise, in numerical, this is the formula that you will use for solving the numerical. So this is the formula for your inclining experiment. So you can learn this formula for numericals, and this principle that we have discussed, which is very simple. You cause the vessel to list, read the list. To read the list, you make arrangement of a pendulum and a graduated scale, and by that you can get you can get this formula for GM, which is small w, that is the weight which is shifted, that is called as an inclining weight. D is the transverse distance through which the inclining weight is shifted. Capital W, L is the length of the pendulum. Capital W is the displacement of the ship in the condition in which experiment was performed. And deflection is the deflection on the graduated scale, which is caused because deflection of the pendulum because of the list caused. Is that clear, beta? Which has to be exercised here, guys, is that, see, we all know that when we say sine theta or cos theta or tan theta, if you remember from school, what are they called as? They are called as trigonometric ratios. Do you agree?
Yes, sir.
A ratio is a comparison. You compare like things. You compare oranges to oranges, apples to apples. So in this tan theta formula, this one, when you're writing deflection upon length, what are you comparing? You are basically taking the ratio of the deflection and the length. Now, what is important is when you have to take this ratio, the unit of deflection and unit of length should be same. Why? Because if their units are different, then they are not like things, then they become unlike, because one you express in meters, other you express in centimeters or millimeters, then you cannot compare them. Why? Because their units are different, and in different units, how can the comparison be done? Do you agree with me, guys? Part of this which you have to take care when numerical is being solved. Usually in our questions, deflection is given in centimeters because it is a small value, so the scale is graduated in centimeters and millimeters. Okay, so your deflection is usually given in centimeters and length is usually given in meters. So both have to be reduced to same unit, and as a normal practice, of course you can change the length to centimeters also, but as a normal practice, what we do is we change the deflection to meters or the same units as the length of the pendulum. Is that clear, beta? Now, every passenger ship, regardless of its size, and every cargo ship having a length of 24 meters and upwards should be inclined upon its completion, means after the shipbuilding, ship is constructed, and the elements of its stability determined. And when it says elements of stability determined, it's basically talking about, is that clear, beta? Flag state, beta, may allow the inclining test of an individual ship to be dispensed with, provided basic stability data are available from an inclining experiment of a sister ship, and it is shown to the satisfaction of the administration that the reliable stability information of the exempted ship can be obtained from the data of the such sister ship, which will be referred to as the lead ship. What is he saying? Shipyard is making sister ships one after the other, and they are practically the same ships being churned out one after the other. Then if the administration feels appropriate, it is subject at the discretion of the administration, they may choose the inclining experiment results of the earlier ship and may exempt the newly built ship, which is a sister ship of the earlier one, to be put through inclining experiment. So, but that is up to the discretion of the administration. If they feel that the data of the earlier ship can be used, then the to get the kg of the exempted ship, then they may exempt this new ship from being inclined and may use the data of the earlier ship. Above point, which we just said, from inclining experiment, the deviation of the light ship mass, the mass of the ship, the light ship displacement of the ship, the deviation from between which two ships, the ship which is seeking exemption of inclining experiment and the ship whose result is intended to be used. So the ship whose result is being intended to be used is called as the lead ship. So if the deviation in the light ship displacement of the ship in question and the lead ship, if for a ship less than 50 meters in length, the maximum deviation in the light displacement allowed is only 2% of the light ship displacement of the lead ship. That means if the lead ship had a displacement of 10,000 tons, light displacement of 10,000 tons, so if the current ship has the and they are less than 50 meters in length, if the current ship, its displacement falls within plus 2% or minus 2% of 10,000 tons, then yes, the administration, if it wants, it can exempt the new ship from inclining and can use the data of the lead ship. Likewise, if the ship is greater than 160 degrees, then this deviation, permissible deviation, is further reduced, and it's reduced to only 1% instead of 2% now. And for lengths between 50 and 160, because you've catered to less than 50, you've catered to more than 160, between 50 and 160, there will be linear interpolation between 1% and 2%. There will be linear interpolation between these two values of 2% and 1%. This is how, if the light ship displacement of the ship in question and the lead ship falls within the permissible limits, then only the administration has the power to exempt. Otherwise, it goes outside the control of the administration also. The center of gravity should not be greater than 0.5% of the length, okay, of the lead ship. So there is a limit that the LCG of the lead ship and LCG of the ship in question, they should also not vary by too much. That means the longitudinal distribution of the weights cannot be beyond outside the permissible limits. So only if these conditions are met, if only these two conditions are fulfilled, then only if the administration wants, it may exempt or may dispense the ship in question from the inclining experiment or class of ships especially designed for carriage of liquids or ore in bulk to be dispensed with. That is, they may allow. Again, please, it's not that they have the right to seek exemption. No, it is the administration discretion to basically do so with, when reference to existing data of similar ship clearly indicates that due to the ship's proportions and arrangements, more than sufficient metacentric height will be available in all probable loading conditions. What is it trying to say is that ships like tankers, ships like ore carriers, they have very low kg. Why they have low kg? Because when you load the tankers with liquid, you cannot start filling up from half the height of the tank. It has to start from the bottom. So that results into low kg of the such ships. Ore being heavy is loaded at the bottom. Again, the kg is low. When kg is low, the GM automatically becomes high. So for such ships or class of ships like tankers or ore carriers, enough amounts they can, and if the yard, they can allow the owner or the yard to use any other method of estimating the kg. Because what is the administration's interest in saying that the kg must be determined through inclining experiment? The interest is from safety. It's not from anything else. That because kg will lead to GM and kg will lead to GZ curve, so the kg of the vessel should be correctly evaluated. Okay. So if the administration, if the yard or the owner of such ships where GM, they will have ample GM up their sleeve, if he puts up another alternative method of assessing the kg, the administration can review that process, and if satisfied, then the administration may allow the inclining experiment of that ship, those ships to be dispensed with. Am I clear about this requirement, beta? Clear? Or passenger ships are concerned? Okay, you have got the light ship kg of the ship when it is built. Fine, fantastic. But what happens after that? There may have been structural changes. So whenever alterations are made to the ship, which can materially affect the stability, or that means the light ship kg, the ship should be re-inclined. The ship should be inclined if there are reasons that changes have been made to the ship's light displacement, which can affect the light ship condition, then the ship should be re-inclined as and when such need arises. Is this point clear, guys? Life is involved. There are many lives is involved. Like you have so many surveys. Passenger ships every 5 years have to undergo a light ship survey. Okay. So for passenger ships, at periodic intervals not exceeding 5 years, a light ship survey should be carried out to verify any changes in the light ship condition and the LCG. For cargo ships, okay, if you, as and when the modifications are made which can materially change the stability, please re-incline. And that above line also applies to passenger ships if it has been made between 5 years of validity. But other than that, even if passenger ships have not undergone any modification, still passenger ships need to undergo a light ship survey every 5 years. And then during the light ship survey, if the displacement of the passenger ship is found to have changed by, light displacement of the passenger ship has been found to be changed by more than 2%, or its LCG has been found to be shifted by more than 1% of the length, if the deviation exceeds these limits, the passenger ship needs to be re-inclined. The passenger ship needs to be re-inclined. So for passenger ships, why is it so strict on passengers, beta? A surveyor or the administrative representative should be present to witness the inclining experiment, and the test results shall be submitted to the surveyor for review. The result of the inclining experiment is to be certified by the administration through its representative, and the same should be included in the approved stability booklet. Like responsibility for making the preparations, conducting the inclining test and lightweight survey, recording the data and calculating the results rest with the owner or the shipyard on the owner's behalf, not on the fleet. Flag state will witness and review and certify. Ship should be as complete as possible. When the ship is being built, before the inclining experiment is performed, the ship should be as complete as possible at the time of inclining experiment. But ideally, it should be complete. But yes, sometimes what happens is, suppose there is one generator which has to come. It's going to take 1 month to come. Then you know the exact weight of the generator. You know where is it going to be placed. So then you can have the experiment conducted without the generator, and you can get the kg in that condition, and then by moments you can allow for the weight of generator to get the kg of the light ships. So the ship is complete as possible at the time of inclining experiment. The test should be scheduled to minimize the disruption in the ship's delivery date or its operational commitments. Left to be completed, because if it's not complete and nearly complete, then the type of amount of work that is left to be completed, that is the masses to be added, like I gave you the example of generator, affect the accuracy of the light ship characteristics. So good judgment should be made whether that equipment which has to come, would it be possible to know its exact mass? Would it be possible to know its exact kg? If so, then yes, you can do the experiment without that weight having actually arrived. If the mass or the center of gravity of an item to be added cannot be determined with a confidence, it is best to conduct the inclining experiment after that particular equipment is placed on board. These are all from the code beta. Staging, sand, debris, etc. on board should be reduced when you are conducting the experiment to absolute minimum. Excess crew or personnel not directly involved in the inclining test should be removed from on board the ship before the test. Should be free of water. Why? Because you will not be able to quantify that water, and that will be like a slack tank, water flowing from one side to another. Water or trapped on deck may shift and pocket in fashion similar to liquid in the tank. Any rain, snow or ice accumulated on the ship should be removed prior to the test. Preferably, all tanks should be empty and clean, or they should be completely full so as to minimize on the free surface effect. The number of slack tanks, absolute minimum, whatever is unavoidable. The density of the fluid in the tanks and the sounding of those tanks should be taken so that you can exactly determine the amount of liquid, whether it is bunker or it is water ballast or it is fresh water. You can exactly determine the weight of the liquid in those tanks, whether full or slack, because you'll know those weights will not be part of the light displacement. So you will need to know those weights precisely as to how much the weight is. The ship should be moved in a quiet, sheltered area from extraneous forces, external forces, disturbing forces, such as propeller wash from a passing vessel or a sudden discharge from a shore side pump. So these external disturbing causes which can affect the list of the ship, they should be avoided. Anything on tide conditions and the trim of the ship during the test should be considered, including sufficient UKC to ensure that the ship will not touch the bottom. The specific gravity of the water in which the ship is floating should be recorded. Why? Because against the drafts, you will be taking the displacement, and therefore you should take the density of the water in which the ship is floating also into consideration. The ship should be moved in a manner to allow unrestricted heeling or the listing. The excess ramps should be removed. Excess ramps are like your gangways beta. Power lines, hoses, etc. connected to shore should be minimum and should be kept slack to avoid any risk of them parting or the ship should be as upright as possible with the inclining weights in the initial position. The ship should be as upright as possible. How do you make it she's upright? Yes, pendulum will be one indicator, other will be the drafts on port and starboard side. The actual trim and the deflection of the keel, if practical, deflection of the keel is hog or sag data, should be considered in the hydrostatic data. That means draft survey, the way you do the draft survey. That means for getting the displacement, you should get the displacement from the tables as accurate as possible. The total weight used to incline the ship should be sufficient to provide a minimum inclination of 1 degree and a maximum inclination of 4 degrees. That means weights which you will shift, they should not just cause about quarter of degree of a list and you should start performing. No, the code says there should be sufficient inclination between 1 degree to 4 degrees. Pendulums is recommended. I have explained the principle with one pendulum. They are saying no, there can be some errors. They recommend that you should use 3 pendulums. If not 3, 2 is the minimum must. Recommended is 3, but 2 is minimum to allow identification of bad readings at any one pendulum station. They allow that if you can't put all the 3 pendulums, never mind. Some of the pendulums you can replace with alternative means of reading the list, like U-tubes or inclinometers. But again, under the approval of the administration. However, this replacement of pendulum is allowed, but not all the pendulums. One pendulum must be retained. So it is recommended that inclinometers or other measuring devices are used only in conjunction with at least one pendulum. Communication should be provided between the central control and the people who are handling the weights which will be shifted from one side to another. One person at the central control station should have a complete command of the experiment, such as for some weights, because some depends on if there is a weight which can absorb moisture from the atmosphere, then its weight can change depending on how much moisture has it absorbed. So your weight should be such that they don't absorb moisture from the atmosphere. But if the weight is such that it has a tendency to absorb moisture, then they must be weighed just before the experiment. Because if the weight does not absorb moisture, then it can be a certified weight with the weight written on it, okay, 10 ton, 5 ton, 3 ton, whatever it is. But if it has a possibility of absorbing moisture, then you need to wait just before the experiment. Each weight should be marked with an identification number and its weight. These weights we are talking about are the ones which will be used for shifting. We have done it with one weight. We don't use one weight. There are 4 weights, 2 on each side. There are 2 on each side which are used. Actually, the process is, we did the principle with one weight. But how is it done? If you have weight 1, weight 2, weight 3, weight 4. Weight 1 goes this side. That is step 1. Weight 2 goes this side. Step 2. Weight 1 comes back. Step 3. Weight 2 comes back. Step 4. 3 comes this side. Step 5. 4 comes this side. Step 6. 3 goes back. Step 7. 2 goes back. Step 8. So after the 8th state shifting, you come back to the same condition as you started with. So actually you use 4 weights, 2 on each side, and it will involve step shifting of 1 weight at a time. And that's how the experiment. And after each shifting, the deflection is noted. Weight movements with 2 weights on each side, as I have just explained. 2 weights on each side will involve 8 distinct weight movements. Pendulum should be as long as possible. They should have length be enough, but they also suggest that they should cause a deflection of at least 15 centimeters on each side. Now, when you do numericals, you may get a deflection of 8.3 centimeters or 7.5 centimeters. Don't worry about what is documented here, because somebody has set that numerical, whatever value is there, will use it. But as far as the code is concerned, it says pendulum should be long enough to give a measured deflection to each side of the upright of at least 15 centimeters. That means when both the weights have gone from port to starboard, the minimum deflection should be at least 15 centimeters on the scale. Generally, this will be possible if the pendulum length is minimum 3 meters. That pendulums between 4 to 6 meters be used. So length of the pendulum is also recommended. Ideally, it should be between 4 meters to 6 meters. To conduct the experiment, you'll need the plans of the ship, you'll need the hydrostatic particulars, and all those things will require. So this lists down the plans that are required for conduct of experiment. So plans required at the time of inclining the experiment are already there on display. You can take a photo. So this is the set of plans people who are conducting will require, the administration and representative will require, and because if he wants to check anything, then he can check against this set of plans which are required for conduct of this experiment. Taken the photo, beta. This is a simple list of plans, right? Except the following. So every compartment was empty. Only number 2 port and starboard DB were full of water ballast. Number 1 DB had HFO of 100 tons. An inclining experiment was conducted in this condition. A weight of 10 tons, kg 10.2 meters, was shifted transversely through a distance of 17.6 meters. Caused a deflection of 8.3 centimeters. So don't worry about the requirement there, okay? This is a numerical, you have to go by the value which is given. In a plumb line that is 8.5 meters in length, okay? Calculate the GM solid and the kg of the light ship. Now, first and foremost, if you recall the principle that we did, first and foremost, it will first give us the GM in the condition in which the experiment was performed. Yes or no, beta? Correct, beta? So now you see, what is the displacement of the vessel when the experiment was performed? What all weights were on the ship? Drafts are not given. Yeah, so the was light displacement plus 2 dB port starboard plus whatever is in 1 dB 100 tons, or I can write, okay, let me write number only, 1 dB plus the small w used for inclining. Correct, beta? Correct? These are the weights on the ship when the inclining experiment was performed, yes or no?
Yes, sir.
Can you give me the light displacement of MV in ship? If you do not know, you can take it from condition number 1, or it is given in the general particulars also.
549.8.
549.8. Does everybody know where the light ship displacement is there, beta? Because if it's a MMD question, then you should know where it is. Okay. Now go to the capacity table, beta. Go to capacity table. Please find out what number 2 dB port starboard. What is their 100% capacity? Port plus starboard.
207.26.
2.4. No, that is cubic capacity, correct? Correct, beta? 414.92 tons. Okay. What is the kg of 2 port and starboard, beta? From their vertical center of gravity? 0.65. So this is what we have done. These tanks are full, so there is no question about the free surface. Okay. Now we go to number 1 dB. First, for W is given directly to me as 100 tons. What is the kg of this number 1 dB, beta?
1.14.
114.
Okay, right. Now, secondly, what is the capacity of number 1 dB?
157.600%.
So that, yeah, and when you multiply by 0.95, it will still be more than 100, correct, beta?
Yes, sir.
So that means by comparing that, do you agree number 1 dB is slack, yes or no?
Correct, sir. Correct.
Okay. What is I of number 1 dB? Now, I'm again warning you, there is a misprint.
657.
Yeah, there is a problem here, beta. अगर तुम पेज 18 पे देखोगे, जहाँ पूरे टेबल्स की लिस्ट है, वहाँ ये 418 दिया है, यहाँ 657 दिया है, correct? Page 18 पे भी I tabulated as so there is a misprint at one of the locations, which is right, which is wrong, I don't know. But in one of the exams, it came taking I as 419. So I'll take 419 because it was mentioned in the exam because somebody realized that there is a misprint. So they specified in that particular exam. I can't answer this question, which one to take. So don't ask me this question that which one to take. You can say that you are taking it from page number 18 or whatever it is. Okay, not from the capacity table where it is given 657 or whatever it is, right, guys? Because I can't really answer. So I am taking 419 from page number 18. Is that clear? So don't get confused next time that how it happened. It was 651. I have told you there is a misprint at one of the two places. I don't know where the mistake is there. Now, so the displacement in the experiment condition is 549.8. plus 2 dB you're saying is 414.92. 1 dB is 100 and small w is 10 tons. How much does this become, beta?
6024.72.
6024.72 tons is the displacement of the vessel in which the experiment was performed. Okay. Now, secondly, we'll come to the slack part later on and the other things we'll do later on. What was our formula? GM in the experiment condition is equal to small w into d into L upon W into deflection. Right, guys?
Yes,
this was the formula. Now, capital W we already have. Look at the question. What is the value of small w, guys? What is the value of small d transverse G?
8.3, sir. 8.3 pm. So 0.083.
D.
17.
And
Yes, sir.
last we need is the deflection, which is 8.3 centimeters. And remember the caution: if length is in meters,
0.0.
it should 0.08 meters. Otherwise, you'll mess it up nicely. Be careful. Now I have everything in the question formula that I need. What I will put the values, and I'll get the GM in the experiment condition. Small w is 10, d is 17.6, length is 8.5, capital W is 6024.72, deflection is 0.083. Can you please calculate and give me what is GM experiment? Guys, any questions up to this point? Let me know if there is any concern. We have got the GM in the experiment condition. 1.132. Everybody to go and see better. Let's not rush through with things.
So can you repeat for what we have to find?
KM in the experiment condition, better. KM in the experiment condition.
KM in the experiment condition with GM 3.058.
Array, I am talking of KM. What has GM got to do with it? I'm asking what is KM in the experiment condition. Why are you reading GM? What has GM got to do with this obtaining of KM, beta? Where will you obtain KM from? I'll get the kg of the vessel in which condition in which the experiment was performed. So kg in the experiment condition would be the difference of the two. So 4, 2 and 2, 8. Then it is 0. Is it 8.084? Am I right? Unless I have made any mistake in subtraction.
074.
Sorry, beta, 0?
7.
Yes, this is 74. 74. Okay, fine. Okay, thank you. 8.074 meter is the kg in the experiment. Guys, can I continue further or somebody is still stuck with kg? Let me know. Kg in the experiment condition, and we have the displacement in the experiment condition, guys. So what have we got through this experiment? We have been able to obtain the kg of the ship. Yes.
Sir, I think this experiment is not 11.05.
Displacement in the experiment condition is 6024.72. So we have got the displacement, and we are all comfortable with these questions that if I know the displacement and I know the kg, and then I know what is to go from the ship, which is not part of the light ship, and what has to come on board if something was to be added to light ship, then I can use the principle of moments and now close out this question. Now what does he want? Calculate the GM solid and the kg of the light ship, guys. Now kg of the light ship will be equal to the vertical moment of the ship in the experiment condition. I'm talking to myself like this. That will be 6024.72 into 8.05. This is the vertical moment of the ship in the experiment condition minus the vertical moments of those weights which do not belong to light ship. There are 3 weights you see here, 1, 2 and 3, which do not belong to the light ship. So minus their vertical moments, 414.92. The kg of number 2 dB you had given me is 0.65 minus 100 into, you gave me 1.14 into, minus 10 into the kg of 10 tons of weight is given in the question as 10.2. That leaves you with the vertical moment of the light ship. And this one divided by, basically you can directly divide by light ship displacement, or if you're using the principle of moments, you can say 6024.72 minus 414.92 minus 100 minus 10. It is effectively coming as 549.8, right guys? And this will give you the kg of the light ship, right? What is the kg of the light ship coming from this question?
8.735.
8.81.
8.7. What are give up to 3 decimal places, guys. Whatever it is coming, I think if they are not matching, then you're making mistakes in calculation only, right?
728, sir. 8.7.
No, my answer that I have put from the last batch is 8.813. I don't know. 9.8. You'll pick up the km from the hydrostatic particulars, beta, light ship km, and from there you'll subtract the light ship kg, and you'll get the GM solid. This will be this will be GM solid for the 2.916. Then this is the answer. Check for any mistakes. If there are no mistakes, then these will be the answers.
Guys, what is